Good morning, one and all. This is Endurkara from AC department. Today we'll see the one-sided unilateral Laplace transforms. Before going to that one, generally the unilateral Laplace transform for the corresponding x of t will be given as, that is Laplace transform of x of t will be equal to x of s, which is being given as from 0 to infinity x of t e power minus st dt. E power minus s. This s will be nothing but our sigma plus j omega. We'll simply keep the s as the sigma plus j omega only. Then solve the corresponding Laplace transform and define the values of the s where it will be exists. Therefore, that will be called as our region of convergence. We'll see it by the one problems. Let us first consider that the first signal as the impulse signal. First signal as an impulse signal delta of t. Now, that is x of t is equal to delta of t. Then the Laplace transform of x of t is equal to delta of t, that is x of s is equal to from 0 to infinity x of t is the delta of t e power minus st dt. As delta of t is being defined at 1 for t is equal to 0 and 0 otherwise. That's why this value will be 1. We'll take the e power minus st at t is equal to 0. At t is equal to 0. That means we'll get the simple value is that t is equal to 0. When we put t is equal to 0, it depends upon the value of s. Here we will get that e power minus t at t is equal to 0. Therefore, when we substitute t is equal to 0, it is e power 0 and e power 0 value will be 1. That is Laplace transform as x of s is equal to 1. That is delta of t whose Laplace transform will be given as s. As there was no s in this particular Laplace transform, that is ROC is for all s. For all s. That is when we plot the s-plane like this. The s-plane on x-axis will take the sigma, on y-axis it is j omega. The entire s-plane is your region of convergence. This is your ROC. The entire s-plane will be your region of convergence. Right? Next, the second signal will be given as the unit step signal. Unit step signal. And this unit step signal will be defined as 1 for t greater than or equal to 0 and 0 otherwise. And 0 otherwise. Now this is our u of t. Next come to the point of taking the Laplace transform. That is x of s is equal to integral of 0 to infinity x of t e power minus st dt. Then it is 0 to infinity. What is x of t? It is u of t. U of t e power minus st dt. As u of t is also being defined from the 0 to infinity, therefore the limits will be the same. That is being given as from 0 to infinity, this is value as 1 e power minus st dt. When we perform the integration, e power minus st by minus s with the 0 to infinity. When we perform the integration, when we put the infinity, e power minus infinity value will be present minus e power 0 by minus s. But when we put the infinity value at here, the s has to be the positive. Unless the s is being negative, but whenever the s is being negative means positive. When we put infinity, this e power infinity value will be present. That is always be an infinity. Okay? The point is that this exponential will becomes the e power minus infinity provided our Re of s should be greater than 0 only. If it is less than 0, that is Re of s will be, that is Re of s should be greater than 0 only. If it is less than 0, this e here will get the e power infinity, then e power infinity value will be the infinity. Therefore, e power minus infinity minus e power 0 by minus s. When the condition is Re of s will be greater than 0, right? Therefore, which is nothing but e power minus infinity is 0 minus 1 by minus s. This minus minus gets cancelled, which is equal to 1 by s. That is u of t Laplace transform as 1 by s, provided this Re of s will be greater than 0. That is, Re of s will be greater than 0. When we plot this particular s plane, taking the sigma has been 0 at here, and here the j omega, let us consider the Re of s will be greater than 0. Greater than 0 means entire this one. At these particular places only, this Laplace transform is said to be exist. Whereas Re of s less than 0 means this entire thing. There this Laplace transform is not exist. Only it exists between for the Re of s greater than 0. For the Re of s only it will be Re of s greater than 0 only it will be exist. Otherwise it is not said to be existed. That is a way of calculating the Laplace transform and its region of convergence. Next comes to the calculation of Laplace transforms of the corresponding ramp signal. Let the ramp signal will be defined as R of t, ramp signal R of t, which is nothing but t into u of t, Then the Laplace transform of this particular one as x of s is equal to from 0 to infinity x of t e power minus st dt. Therefore 0 to infinity, what is x of t? It is t into u of t, which is e power minus st dt. Therefore it is equal to, then as the u of t will have the same limits from the 0 to infinity, t into e power minus st. This is the integral of uv method. That's t, keep the t as t, perform the integration for exponential e power minus st by minus s, minus t derivative as 1. Again this part will have to take the integration, that's e power minus st by minus s whole square. The limits will be from 0 to infinity. Here also the same case, when we put the upper limit on the two exponentials, that's here infinity, here infinity, it depends upon the value of s. If the s value is, that is Re of s is greater than 0, then only this will get the e power minus of infinity, then we'll get the upper limit as e power minus infinity. That is, whenever the Re of s will be less than infinity, then we'll get e power infinity. This e power infinity will be infinity, e power minus infinity is 0. Therefore, we'll take the region of convergence as this one, and will not consider this particular region of convergence as the region of convergence. As it becomes the infinity at here, this is not our region of convergence, this is our region of convergence. Therefore, taking that as the region of convergence, this entire integration can be written as t into first. Then when we put the upper limit as infinity, that will be gone. This particular one, infinity into anything, that's e power minus infinity 0, minus lower limit is 0 into e power 1 by minus s. This entire thing will be gone, infinity minus something by, that's why this will be gone. Next here upper limit e power minus infinity minus e power 0 by minus s whole square. Minus s whole square means s square only. Okay, when we solve this particular one, that is e power minus infinity 0, then minus of minus is plus, minus 1 by s minus s whole square. Numerator 1 and the denominator s square. 1 by s square, provided that Re of s will be greater than 0. That's why the ROC that's ROC region of convergence will be plotted by taking the sigma on x-axis and j omega on the y-axis. As Re of s will be greater than 0, that's why this entire thing will be our region of convergence. This is your region of convergence. When it is greater than 0, it must be the greater than 0. That is the ramp signal. Coming to the parabolic signal. In the parabolic signal, that is x of t is equal to, it is t square into u of t. Therefore, our x of s as minus 0 to infinity x of t e power minus st dt. Therefore, substitute what is x of t. That's 0 to infinity. X of t is t square into u of t e power minus st dt. Thus u of t will have the same limits from 0 to infinity. Therefore, it will maintain the same limit 0 to infinity t square e power minus st dt. Then t square into e power minus st by minus s minus. Next, take the t square derivative. It is 2t. Again e power minus t st by minus s whole square. Again the derivative for 2t. Here the plus 2 e power minus st by minus s whole cube. And the limits will be from 0 to infinity. When we put infinity at here, it will be that this term will be infinity only. Again, when we put infinity at here, this term is also infinity. That's why infinity minus 0 by minus s plus minus infinity minus 0 by minus s whole square plus here 2 into, next when we put infinity at here, e power minus infinity. You are to get this minus infinity, the s should be how it should be. It should be given as Re of s should be greater than 0 only. Then only we can write this e power minus infinity. Otherwise, when the Re of s will be less than 0, here we can write the e power infinity, right? That's we have taken the R region of convergence as ROC as Re of s will be greater than 0. Then only we can write this as e power minus infinity minus e power 0 by minus s cube. Therefore, it is equal to, hence it will be equal to 2, this value as 0 into minus 1 by minus s cube. S minus minus gets cancelled, 2 by s cube, provided that Re of s will be greater than 0. Therefore, that particular Re of s will be given like this. This has the sigma Re of s. For the positive section, it will be the ROC. Re of s will be greater than 0. In every case, we have gotten that a region of convergence has Re of s will be greater than 0. Okay, that is the Laplace transforms of ramp signal.